Okay. Uh, Hi everyone. Welcome to the ECON 2 review session. We'll be covering chapters 1 to 12. Uh, it'll cover almost all the important topics that are there in chapters 1 to 12. Okay. Let's start. We start with opportunity cost and budget line. Budget line is basically connecting all the points uh, with the given income, where all the points are just combinations of attainability of two products. So if I have a given amount, if I have a given amount of money as income, what are the different possible combinations of two goods that I can buy? And joining all those points gives us the budget line. And then opportunity cost of a good is just uh, if I want to produce one more unit of that good, or if I want to consume one more unit of that good, how much of the other good do I need to let go? So in this case, the opportunity cost of one beer here is two pizzas. And then we move on to production possibility curve, which is basically a curve representing all the possible combinations of goods that can be produced in an economy. Any point within the inside the curve in the shaded region is also attainable, but it's not considered to be an optimal utilization of resources because we can always produce more in the economy with the given resources we have, and any combination outside this curve is unattainable because we don't have enough resources to function at that combination. Okay, so let's move on to an example. If it takes 1 hour to make a birdhouse and 5 hours to make a dresser, what's the opportunity cost of both the goods? So for the birdhouse, the opportunity cost of one birdhouse is a fifth of a dresser because a birdhouse takes an hour, and within that hour we can finish a fifth of a dresser because a dresser takes 5 hours. Same logic for the dresser. The opportunity cost of one dresser is 5 birdhouses because it takes 5 hours to make a dresser, and in 5 hours we can make 5 birdhouses. Okay, so that was everything in chapter 1 and 2. That was technical. And okay, let's move on to chapter 3. Okay, now we start with demand. So demand is the entire relation between quantity demanded and price, and it's really important to understand the difference between quantity demanded and demand. Quantity demanded is the actual amount of a good or service that the consumers want to purchase for a specific price point. And combining all of these different points with all of the respective quantity demanded is what gives us the demand curve, which is the entire relationship between quantity demanded and price of the good. And then when it comes to movements with respect to the demand curve, we can either move along the demand curve or we can shift the demand curve. A movement is when there's a change in the price of the good itself, and a shift is when there's a change in factors other than the price of the good. So like price substitutes, income, price of complementary goods, and so on. Okay, so this is what the demand curve looks like, and it's inversely related to the price. And a movement along the demand curve is basically if I move from, let's say, point Y to point V, and that happens when there's a change in the price of the good itself. However, let's say our income increased, that would shift this entire relation, which is the entire demand curve, to the right. Okay, let's do a few examples. Let's think of our good as coffee, and then we'll try to see what happens to the demand curve if the price of tea increases and falls. What happens to the demand curve if the price of coffee decreases or increases, and then what happens if the consumer income changes. Okay, so when the price of the tea increases, your demand curve shifts to the right. Now, why is that? It's because since tea is a substitute good, when a substitute goods price increases, your own good becomes relatively cheaper, and that's why people start shifting to coffee more. So the entire demand curve shifts to the right. And same logic goes for when the price of tea falls, or tea becomes relatively cheaper, and that's why the demand for coffee shifts to the left. And then if the price of coffee decreases, since it's a change in the price of the good itself, we just move downwards and towards the right. So along the demand curve downward towards the right. And same logic for when the price of coffee increases, we move upwards and left. And then if the consumer income increases, we now have more purchasing power, so we can buy more coffee. So the entire demand curve shifts to the right, just basically saying the demand increases. Okay, let's move on to supply. Same logic. The quantity supplied is the actual quantity that a producer is willing to supply for a particular price point, and that entire relation between quantity supplied and price is called supply. Supply is positively related to price because think of it this way. So if you're a producer and the price of a good increases, you would want to sell more of it because you want to earn more. That's why there's a positive relation between quantity supplied and price of the good. And same logic for movements versus shift. So movement is when there's a change in the price of the good itself, and a shift is when there are change in factors other than the price of the good itself. This is what the supply curve looks like. It's a positively sloped curve. And again, movement is just movement along this curve from one point to the other, and then the supply curve shifts when it's external factors other than the price of the good. Okay, these are some example questions that follow the same logic. You can try these questions yourself. The answers are in the slides as well. Okay, let's move on to market equilibrium. Market equilibrium is basically the point where quantity demanded is equal to quantity supplied. And that's where the market sustains. And the reason it doesn't sustain at any point above or below that is as follows. So let's say we are trying to function at a point above the equilibrium point, which is point E, where the curves intersect. Any point above this point, let's say at a price of 100, would give you an excess supply, because at a price of 100, the suppliers are willing to supply this quantity, but the demand is only this much. So what this excess supply would do is it would put a downward pressure on the price, because suppliers are not willing to sell all of these excess goods in the economy. So that would push down the price so that the suppliers can sell these products in the market. And then as price falls, there's movement downward on both the curves. We move downwards on the supply curve, we move downwards on the demand curve, and we ultimately reach the equilibrium. The same logic goes for when we try to function below the equilibrium point. There's excess demand let's say at the price of 20. This is the quantity demand, this is the quantity supplied, and this would put an upward pressure on the price, which would force suppliers to increase their prices, and that would lead to a movement upward along the supply curve, and a movement upward on the demand curve until we reach point E. Okay, let's look at an example question. So this is a really simple intersection question. You have a supply and demand equation. Quantity demanded is a function of price, and quantity supplied is also a function of price. And the equilibrium price and quantity is just equating these two equations. So now you have two equations being equated with one unknown variable, that's the price, and solving this gives the price of 15. Once you have this, you can put P back into both of the equations to find the quantity, and you would get the same quantity for both equations, because that's the definition of equilibrium. It's where both the quantities are equal. Okay, let's move on to chapter 4. So price velocity of demand is basically trying to understand how sensitive the demand is to a change in price. So if that's saying if the goods price changes by X percentage, how much would the quantity demanded for that good change by? And there are 5 cases. The first one is perfectly inelastic demand, which is basically saying that for any given change in price, our demand doesn't change at all. So the denominator could be as big as it can, and then the numerator would always be zero because there's no change in demand. So that's perfectly inelastic demand. The exact opposite to that is perfectly elastic demand, which is even if there's no change in price, the change in demand is infinity, just because here you would have the denominator as zero, which would make the result infinity. These two are just theoretical concepts. We don't see this in real life. Then we have inelastic demand, which is basically saying that the percentage change in price is more than the percentage change in demand. So the consumers demand is not that sensitive to changes in prices. And the exact opposite to that would be elastic demand, which is saying that a very small change in price can lead to a higher percentage change in demand. And so elasticity here is greater than 1, elasticity here is less than 1, and then unitary elastic is basically saying the percentage change in price is the exact same as the percentage change in demand. So you get a value of 1, and yeah, it's called unitary elastic. Another thing to notice is as we move down the demand curve, the elasticity falls. And that's because we're looking at the same change in price, but for a higher amount of quantity. So yeah, that's just the reason elasticity falls as we move down the demand curve. And then it's the same logic for supply elasticity. You have perfectly inelastic, you have perfectly elastic, you have unitary elastic, elastic, and then inelastic. The logic is exactly the same. Okay, let's move on to what determines elasticity on a subjective level. So for demand elasticity, if there are more substitutes available in the market for your good, the higher would the elasticity of your good be. Because think of it this way: if the price of a good increases and I can easily substitute that good for any other or like multiple goods in the economy, then there's a higher chance I'm more sensitive to price changes. And then when it comes to long run and short run, in the long run, the elasticity is higher just because it's easier for consumers to change preferences in the long run compared to changing preferences in short run. Okay, coming to supply elasticity, it's the same logic in terms of substitution. So if there are many substitutes available for the product, another thing that plays here is the production cost. So if there are many other substitutes, and let's say the production costs are lower to shift production from one good to the other, then the elasticity would be higher. And the logic for long run versus short run is again the same. In the long run, it's easier to shift the production from one good to the other, so you have higher elasticity. Okay, this is a really important concept to understand, which is the burden of tax. So if the demand is inelastic and the supply is elastic, the tax burden is more on the consumers. But if the supply is inelastic and the demand is elastic, the tax burden is more on the supplier. And we can see graphically and logically both it makes sense. So let's look at the left graph here first. So let's say there was a tax introduced that shifts the supply curve upwards by the tax amount. And then we can see how the burden is split on the price axis here. So initially the equilibrium was E0, and then the new equilibrium is E1. And the difference with the gap between the two supply curves is the tax. And the burden on the consumer is PC minus P0, which is a higher part of the tax compared to PS minus P0, which would be the burden on the supplier. And the logical reason for that is when we know consumers are not that sensitive to price changes, or in other words, the demand is inelastic, we can push more of the tax burden on the consumer without impacting the quantity that much. And then the same logic goes for the graph on the right here. Here, the burden on consumers is less and the burden on producers is more. And the logic says that when we know the producers are not that sensitive to price changes, it's easier to push more of the burden on the producers without impacting the quantity too much. Okay, and this is just from the textbook. This might be helpful for a few questions on the final. What you would be given would be the quantity demand and the quantity supply equations, and then the amount of the tax P. And then you would be asked to compute the burdens for producer and the supplier, the producer and the consumer. And the way that works is, so you have these two equations, and equation 3 basically comes from here. So PS is basically this whole line PC minus the tax, right? Like this gap, and this gap is just the tax. So the price, the price for the supply can be written as PC minus tax. So that's this whole thing minus this, and that would give you this PS. Once you have this, now you can write both of these equations in terms of PC and then solve for PC. And you would get something like this. These variables are just going to be constants, like A, B, C, D, and T are going to be constants. So you're going to get a constant value here. And once you have PC, you can calculate PS by just subtracting T, and then you can also calculate the quantities by just plugging in PC. Okay, now let's quickly talk about income elasticity of demand. Just like, so when we were talking about price elasticity of demand, we were trying to see how sensitive demand is to changes in prices. Here we're trying to see how sensitive demand is to changes in income. And this elasticity varies for different types of goods. So for normal goods, which are most of the goods in the economy, as your income increases, your demand for normal goods will also increase because it's basically your purchasing power increases. For inferior goods, as your income increases, you would want less and less of inferior goods, and you would want to shift more to normal goods. So there's negative income elasticity. And then lastly, it's different for luxuries versus necessities. So if an item is a necessity, your income elasticity would be lower because it doesn't really matter what your purchasing power is if you have to buy the good, if it's a necessity. So you have a lower income elasticity for necessities versus for luxury items. A higher income would push you more to buy luxury items. And then cross elasticity of demand is basically, again, seeing the sensitivity of the demand of a good to changes in prices of a substitute or a complementary good. So for substitutes, it makes sense that the cross elasticity is positive, because if the price, let's say if the price of tea increases, that would make coffee relatively cheaper. So the quantity demanded for coffee would go up. That's why the cross elasticity is positive for substitutes, and then following the same logic, the cross elasticity for complements is negative. Okay, let's move on to chapter 5. So the concept of price floor and price ceiling is basically putting a threshold on price in the economy above or below which a good cannot be sold. So in terms for price floor, it's even though it's above the equilibrium, it's kind of a threshold below which the economy can't function. So I cannot function at any of the prices below P1. So it's kind of like a floor. You can't go below a floor. So following that logic, you have to function on at least P1. And as we saw earlier, functioning above the equilibrium would lead to an excess supply situation. And usually when there's excess supply or excess demand and you have like two quantity points, the economy always functions on the lower point. It's just because if you have a higher higher supply in the economy, but not enough demand, doesn't really matter what like if you have extra products, no one's going to buy that. See, the point at which the economy would actually function is the lower quantity. Same with excess demand. If you have more people wanting a good, but the supply is low, doesn't really matter. The economy is going to function on the lower quantity because you can't have more than that being supplied. So in the case of price versus excess supply, we function on the economy functions on Q1. And one of the examples of a price floor could be like minimum wage. Okay, so price ceiling is the exact opposite. Think of it this way: it's kind of a ceiling, so you can't go above that. So it's a lower threshold. So nothing can be sold above a certain price. For instance, like rent controls is a good example for price ceiling. There are a lot more examples in the economy. What's important about this case is that it can lead to black markets, which is basically saying that even though in the economy we're not supposed to sell above the price of P1, what suppliers might do is take those goods and give it to the people who are willing to pay price P2, because for quantity Q2, there's a point on the demand curve corresponding to price P2 where people are willing to buy for that price. So they might just take those goods to those people and sell it at a higher price. And this green shaded region is the potential black market profits. Okay, and both of these situations are called market inefficiencies. Before understanding deadweight loss, we need to understand what consumer surpluses. So instead of thinking about this like smaller shaded triangle, think of it this way. Let's say this whole bigger triangle region here was shaded to the left of the equilibrium point. That's your whole consumer surplus and the producer surplus. That's the whole economic surplus when the economy functions on point E. But since there's a cap on the price, we're not able to function on point E anymore. So here we function on Q1, here we function on Q2. So all of this surplus is not captured. And the part that's not captured is what we are not able to function on. So we are not able to function on Q0. So this region between Q1 and Q0 is the surplus that the economy is not able to capture. And that's what's called deadweight loss. Okay, moving on to chapter 6. Now we come to consumer theory, which is basically how consumers make their decisions. We start with marginal utility. So utility is the happiness you get out of consuming a good or service. And marginal utility is the additional utility you get from consuming one more unit of that good or service. And the law of diminishing marginal utility says, as you consume more and more and more of a good or a service, the additional happiness you get keeps on decreasing. So like after consuming like 10 ice creams, like when I consume the 11th ice cream, it's not going to give me a higher amount of happiness than it did when I initially started consuming ice creams. I'm going to get a stomachache or something. So yeah, that's the basic idea. So going by that logic, the total utility curve initially increases when your marginal utility is positive, still falling, but still positive. So your total utility is increasing, but at a decreasing rate. And then once your marginal utility reaches 0 and then becomes negative, your total utility starts falling. So that's why it kind of looks like a hill. Okay, now, if a consumer has to choose between consuming two goods and what quantity of two goods should the consumer consume, it's not enough to compare just the marginal utility. You also need to bring in prices. For me, it's usually easier to understand it using the way it's written the first way, but it's the same logic. So what we do here is, instead of comparing just the marginal utilities, we compare the ratio of marginal utility to that goods price for both the goods. And the reason for that is as follows. So let's say there's a situation where these ratios are not equal. So just take this px to the bottom here and take this mu of y to the top here. So when this mu of x over p of x is less than mu of y over p of y, what it basically means is that the additional utility I get from good y, from one more unit of good y with respect to what I paid for that unit, is more for good y than good x. And that's why I would, if I want to increase my consumption, I would increase my consumption of good y, because for the price I'm paying, the happiness I'm getting is more for good y. And same logic goes when mu of x over p of x is greater than mu of y over p of y. And in both of these inequalities, when we consume more of one good, that would make the marginal utility of that good fall down. And it's going to fall down until we reach this equality. Yeah. So yeah, that's the basic logic. Okay, now we come to income and substitution effects. So when we say price is inversely related to demand, that downward slope, that movement along the demand curve, comes from two effects. One is the substitution effect, which is basically saying that the quantity of a product demanded can like change because of its relative price changing. And then the income effect is basically saying that there's another effect that adds to that, which is your purchasing power. So and it's different for all three types of goods, and we'll look at the graphs of that. So for a normal good, both income effect and substitution effect work in the same direction. So for a normal good, when the price, let's say, falls from P0 to P1, that's making your good relatively cheaper to other goods. So that increases the quantity demanded. So that's one effect in that direction. And then when the price of a good, of a normal good falls down, it also increases your purchasing power. And by purchasing power, I mean, so let's say, for instance, a pack of coffee was $10 and it falls to 2.5. So with the same amount of money, I can now have four packets of coffee. So with the same amount of money, my purchasing power is increasing. So that's another push in the direction of increasing the quantity demanded. So both income effect and substitution effect for normal goods work in the same direction. And that's why you get a more elastic curve here. But in the case of inferior goods, the substitution effect works the same way. It's because a substitute for an inferior good is another inferior good, right? So when the price of an inferior good falls down, it's cheaper relative to other inferior goods. So the substitution effect works the same way, in the same direction. It increases the quantity demanded, but the income effect here would work in the opposite direction. Because if you have a higher purchasing power, you would want to substitute away from inferior goods and towards normal goods, just like we saw in the case of income elasticity, that higher income reduces your demand for inferior goods. Going by the same logic, you get the income effect in the opposite direction, and that's why you have a more inelastic demand curve. And then giffen goods are just a special category of inferior goods where the effects are exactly the same as inferior goods. So substitution effect works towards increasing the quantity, but the income effect works towards decreasing the quantity demanded. But here the income effect is big enough to outweigh the substitution effect, and that's why you get a slightly positive positively sloped demand curve. Okay, let's talk about consumer surplus. So consumer surplus is the difference between the total value that consumers place on all the units consumed uh, and what they actually pay to purchase that amount of the good. So think of it this way. So for all these different quantities, the consumers are paying $1. The surplus here is for each of these units. It's the difference between uh, the price uh, the price on the demand curve. So if you take the middle points of all these graphs and you like join them, that'll give you the demand curve. And so for all of these quantities, the difference between 6 and 1, let's say this is 3, so 3 and 1, and so on until we reach the market price. The sum of all these areas is the consumer surplus. So if you look at the graph on the right here, that's exactly this orange shaded region, which is for all these points, it's the difference between the price on the demand curve and the actual price that's being paid. And the same logic goes for producer surplus. And once again, so the sum of these two is the total economic surplus. And as we saw, whenever we put a cap on the prices, not all of this surplus is captured, and we get the little triangle, the purple triangle we had here as that bit loss. Okay, this could be one of the questions you see on the finals, which is what's the change in consumer surplus? So let's say we initially had this supply and you had demand, and your initial consumer surplus was this dark green triangle, and your initial producer surplus was this orange triangle. And then there's a subsidy which shifts the supply curve to the right. Whenever you get a subsidy, your production costs go down, so the supply curve shifts to the right. And then the question is, find the change in consumer surplus. So the new consumer surplus we have here is this light, the dark green area plus this this area as well. So it's like this whole big triangle from this point to this point at 25 to this point at 15. This whole bigger triangle is the new consumer surplus. So the change is just the difference between the new one and the old one, which is this highlighted area that has been split into two parts. So you just calculate the area of this little triangle and then this rectangle and add them both, and that's the change in the consumer surplus. Okay, let's move on to chapter 7, which is about production and producers. So production function is basically a way to relate what's being produced to what was used to produce that. So Q is the quantity that was produced, and it's a function of the inputs being labor and capital. And this is just to like keep it simple. There could be other inputs, and there are more complicated models, but this is just the very basic foundation of it. You have labor and capital, and a function of that gives you a relation between those inputs and the quantity that's being produced. Accounting profits and economic profits. The difference between economic profits and accounting profits is that economic profits also includes implicit costs. So yeah, that's the only difference. And then we look at production in all three time periods. So you have short run, you have long run, and you have very long run. And the difference is, in the short run, you have some factors of production, so some inputs that are fixed. So you can't change the quantity of those inputs. So for instance, capital, in the short run, capital is fixed. You can't change that. But in the long run, you can, every factor is variable. So you can change the quantity of labor, you can change the quantity of capital. So there's no fixed factor in the long run. But in the long run, the technology is fixed. And that's the difference between long run and very long run. In the very long run, even the technology can change. Sorry about that. Okay, let's talk about short-run production. So you have some concepts uh, uh, that apply to both that apply to production in general. So total product is uh, the total amount of any good that's being produced. So yeah, total product. And then average product is the total product divided by the number of variable units that were used to produce it. So in the short run, that would be labor. And since capital is fixed, it's not termed as variable. And then marginal product, just like marginal utility. Marginal product is the change in the total output that comes from just using one more unit of variable factor. So if I increase my variable factors by one more unit, how does that change my total product? So that's the marginal product. And then law of diminishing returns. We'll see that when we look at the graph. It's basically saying that as we increase the number of variable factors more and more in production, each factor's marginal contribution keeps on going down. So like, let's say you have a factory and you have 100 employees working there. If you keep on hiring more and more and more and more employees, there would be a point where each additional hire is adding less and less to your total production. So yeah, that's the logic. And then we'll look at this in the graph as well, that marginal product always intersects the average product curve at average product's maximum level. And we'll also look at this in a logical way, which will make it more understandable. So yeah, we also have costs in the short run. So again, so total cost is the sum of total fixed cost. So there's a fixed cost that's just a one-time fixed cost in the short run. And then you have total variable cost, which is the more variable factors you have, the more would be your total variable cost. Total fixed cost is something like you got a building. So like that's just total fixed cost. Total variable cost varies with the number of variable factors you have. Average total cost is again dividing total cost by the quantity of variable factors, and then you kind of get a similar relation between these two equations where TC is equal to TFC plus TVC. If I just divide the whole equation by the quantity, then that gives you ATC is equal to AFC plus ATC. And then marginal cost is basically what's the addition to your total costs when you have one more, when you increase the quantity by one. So, and marginal costs are always marginal variable costs because fixed costs, the fixed costs do not change, right? So fixed costs are fixed. So marginal cost always stems from variable cost. So it's also called marginal variable. Like you can call it marginal variable cost. And then MC will always intersect the average cost and the average variable cost curve at their minimums. And we'll see a logical way to interpret this as well. And capacity is where it's just a term. It's the point where your average total cost is at its minimum, and then it starts increasing. Okay. And okay, so let's look at the curves. So as we said, marginal product intersects average product at its maximum. And the reason for that is, so as long as marginal product is above average product, so that's saying that as long as marginal product is greater than average product, it means that every additional unit of labor is adding more to your product, to your total product, than what an average labor was adding until now, right? Because average product is less than marginal product. So every extra unit of labor is adding more than what uh, each unit of labor was adding on average. So, and that uh, additional uh, additional addition to the product is split between all units of labor when we calculate average product, because again, average product is dividing total product by the quantity of labor. So that extra addition is split between all units of labor. So that's why average product is still increasing. And that's why marginal product intersects average product at its maximum. Once marginal product is lower than average product also starts falling. And then let's look at the cost curves. So the marginal cost curve intersects average total cost and average variable cost at the respective minimums. And then, so there are a few things that are important to keep in mind looking at all the cost curves. The first thing was this, that marginal cost curve cuts ATC and AVC at their minimums. The second thing is the gap between AVC and ATC will keep on decreasing as the output increases, but these two curves would never meet. And that's because the difference between these two curves is average fixed cost, which keeps on decreasing as we increase output, but is never zero, because average fixed cost is just total fixed cost, which is fixed. And as output increases, you're just increasing the denominator. So it gets smaller and smaller and smaller, but it never becomes zero. And that's why these two curves never meet, but the distance between them, the gap between them gets smaller and smaller. And then the third thing that's important to notice is that the minimum point of average variable cost comes before the minimum point of average total cost. And that's because when average variable cost reaches its minimum, average total cost is still falling because of falling average fixed cost, because ATC includes both AVC and AFC. And once average variable cost reaches its minimum, there's still downward pressure from average fixed costs on average total cost. So it's still going to fall a little bit more. So yeah, that was about the cost curves. And now when we look at these two graphs together, it's the important thing that you need to keep in mind is that the maximum of marginal product coincides with the minimum of marginal cost, and that the point where MP intersects AP is the point where MC intersects AVC. Yep, and that's almost everything you need to know about these graphs. Okay, let's move on to chapter 8, which is produces in the long run. So as we said, in the long run, nothing's fixed. None of the inputs are fixed. You can think of capital as variable now. So so for producers now the problem is it's a trade-off between the quantities of both the factors, like how much capital to use and how much labor to use. And it's easier to kind of think on similar lines as when a consumer was making choice between consuming two different quantities of two different goods. We compare for both labor and capital, we compare the ratios of their marginal products to their respective prices. Again, you can take this P of K to the denominator here and this MP of L to the numerator here, and think of it as the respective ratios of what's the addition these variable factors give to the total product with respect to the price for these factors. And then going by the same logic, we need these ratios to be equal, because if let's say if the marginal product of capital with respect to what we paid for that capital is more compared to labor, then we would want to get more capital in our production process, right? So it's the same logic, just between labor and capital instead of two goods. The long run average cost curve also has the same shape. It's shaped like a U, but it has 3 stages. And before we move on to those 3 stages, all the points on the LRAC curve are basically the lowest possible cost of producing at each level of output. In the short run, we weren't able to do that because we couldn't optimize the level of capital because capital was fixed. But in the long run, since all the factors are variable and we can optimally choose their quantities uh, using this equation, you all the points on the curve are basically the optimal cost you can have, the minimum cost you have for each level of output. And that can be seen, like another way to interpret it as you can divide this long run period into short run periods, and then whatever the minimum cost for that short run period is, joining all those dots for all the short periods would give you the long run average cost curve. Okay, so the three stages are as follows. First, you have decreasing costs and increasing returns. And this is very similar to the short-run graph, where, so when the cost was decreasing, the marginal product was increasing. So same logic here, just in the long run. Then you have constant returns and constant costs. And the point at which that's achieved for the first time is called the minimum efficient scale. So you can call any point the minimum efficient scale if it exhibits constant costs. And then then you have increasing costs and increasing returns, and it's similar to the short run graphs in the sense where after a certain point your marginal cost starts increasing and your marginal product starts falling and your average product starts falling. Yeah, these are the three kind of phases of the long run average cost curve. But at all of these points, irrespective of if the curve is falling down or going up, these are all the minimum cost points for the respective outputs, because we can optimize the quantity of labor and capital both. Okay, and then for shifts in long run average cost curve, the costs go up, the curve shifts upwards if there's a rise in the prices of inputs. So if wages increase, or if the price for capital increases. And then similarly, so going by the same logic, if the prices of inputs falls, or if there's like a technological improvement that reduces costs, the LRAC curve would go downward, would shift downward. Okay, let's move on to chapter 9, where we talk about different kinds of markets, and we'll start with competitive markets. So perfect competition is it's kind of an ideal market. It's hard to see. It doesn't happen in real life. It's more theoretical in nature. And the characteristics are as follows. So you have homogeneous products, which is saying all the products in the market are same. There's perfect information everywhere. And you have a large number of small firms. There's no barriers to entry and exit. So any firm can enter, any firm can exit. And then the price is equal to average revenue equals to MR, and we'll see why that's the case. So again, so total revenue is price times quantity. That's what a firm earns in totality. And then you have average revenue, which is just total revenue divided by the units that were sold. And as you can see, this would make average revenue equal to price if I just like take Q here. And then marginal revenue is what's the change in total revenue if you sell one more unit of a good. And the reason this is equal to price is as follows. So look at the first graph here. The firms in perfect competition are price takers, which is to say that the industry as a whole decides what the price is going to be, and an individual firm has no impact in determining what the equilibrium price is going to be. So that is to say, like, a firm can decide to, like, increase or decrease quantity by as much as they want. They're not going to impact the price. The price is set by the market, and each individual firm is a price taker. And that's why you have price equals to average revenue equals to marginal revenue, because marginal revenue is just whatever you get from selling one more unit of good. And since the price is fixed, what you're going to earn from that extra unit is just the price itself. So MR equals to AR equals to price is what we get in a perfect competition setting. Okay, so when it comes to profit maximization, profits are always maximized at marginal revenue equal to marginal cost from a producer's perspective. And the reason for that is, so let's say marginal revenue is let's say we are at a point where we are to the left of Q star here, and here marginal revenue, which is just this flat line, is greater than marginal cost. What's going to happen is that every additional unit I produce, it's adding more to my revenue than it's adding to my cost. So I'm making a profit, right? And I'm going to keep on doing that until I reach a point where producing an extra unit doesn't give me a profit anymore. So that's MR equal to MC, because after this point, so to the right of Q star, when M marginal cost is greater than marginal revenue, each additional unit is adding more to my cost than it is to my revenue. So I'm going to make a loss. I'm just going to stop producing that. So that's why the profits are maximized when you've exploited all those possible options where you can get a profit out of every extra unit. So that's MR equal to MC. Shutdown price is just the price at which where at least the minimum, at least all the average variable costs are met. So this point right here, that's the shutdown price, because you would not want to be below the point where you're not even able to cover your variable costs. And then what's the actual amount of profits here? It's total revenue minus total cost. Total revenue is price times quantity, which is this big area. And then total costs are quantity times average total costs, and that's this area. And subtracting one from the other gives you this shaded region, which are the maximized profits. The supply curve. So the supply curve here is basically the part of MC that lies above the average variable cost. So this part right here is the supply curve, because you would definitely not want to supply below this point, because then you're not even covering your average variable cost. So all the points after this quantity, so this part of MC is basically a supply curve. And then the whole industry supply curve is the sum of all individual firm supply curves. So in the short run, you can have each firm either making losses, no profits, or positive profits, depending on the cost for the firm. But in the long run, in perfect competition, the economic profits are zero, and that's because, so let's say if firms are earning profits in the short run, in perfect competition, there would be new firms that would want to there would be new firms who would want to enter the market in the long run. And once new firms enter, that will shift the market supply curve to the right, which will decrease the price. And as price decreases, your profits are going to go down and down, and it's going to reach to the point where the profits are zero. Same logic goes for if firms are making losses in the short run, then firms would want to leave the industry. And as firms leave the industry, the supply curve shifts to the left, and that increases the price. And ultimately, all the losses go away until the profits are back to zero. So that's kind of the whole logic, that in the long run, firms can leave or enter the market and change the prices such that economic profits are zero. And that's just the graphical representation of what I just said in words. Yeah, okay. So yeah, the long run equilibrium looks like this, where existing firms are already maximizing profits. But by maximizing profit, it means that there are no profits or losses in the economy, and each firm functions on the minimum of their long run average cost. And as we see again, the point at which we are functioning leads to no economic profits. Okay, let's move on to chapter 10. Okay, so now we start looking into monopolies. And unlike perfect competition, where the firm was just the price taker, so the demand curve was flat. Here, the demand curve would be downward sloping because the monopolist is the price maker, right? There's only one monopolist, and the monopolist can dictate whatever price it wants. So here, the marginal revenue would not be constant, and it would actually be below the demand curve. And the logical way to think about it is as follows. So let's say I go from a price of 6 to 2. That means that doesn't mean that I'm reducing the price from 6 to 2 only for these many units. I'm reducing that price for all the units before that as well. So that means that fall needs to when my marginal revenue curve is going towards the right with the quantity. So as I increase quantity, I have to compensate for that fall in price by a higher magnitude on the marginal revenue curve. Because here, let's say, like if I when I decrease the price from 6 to 2, I have to decrease the prices on all the previous quantities. But marginal revenue by definition is the revenue you get from an additional unit. So that fall in price on all the goods needs to be compensated by even a higher fall in marginal revenue for that next unit. And that's why you have a marginal revenue curve that's lower than that's below the demand curve and is way steeper. The profit maximization again always happens at MC equal to MR. We'll look at the logic why. But now here, the curves are a bit different in perfect competition. So the MR equal to MC point is somewhere here. And so the economy should have functioned at so MC is the supply curve, so MC and AR is the demand curve, so it should function somewhere here, right? But since a monopolist wants to maximize profits, and that happens at MC equal to MR, which is at this point US, we would have some deadweight loss in the economy because we're not functioning at the equilibrium point. And this is what allows monopolists to maximize profits. And since the price is greater than the average total cost, the monopoly makes economic profits even in the long run. Yeah, so the output is lower than a competitive market, and that's than perfect competition, and that's because the MR curve is not equal to the price, nor is it equal to the demand curve. There's a deadweight loss, as I said, and then since the price is greater than the average total cost, you have profits because you're selling at a price that's higher than covering your average total cost. But so unlike perfect competition, in monopolies, there are entry barriers. These could be natural barriers or artificial barriers that were created. For instance, uh, patent law. You have governments restricting some industries to themselves. These could be natural or created barriers, but there are barriers to entry when it comes to a monopolist market. Uh, Cartels are basically a group of firms that a small number of firms that come together and agree to act as a monopoly. And the OPEC oil cartel is an example of one of the cartels that led to the OPEC oil crisis. Uh, and then, uh, but if too many firms enter the cartels market, then the whole point of being a cartel diminishes. So, uh, a cartel is always small amount of firms that act together as one monopoly. And then monopolists can easily price discriminate, and the ability to price discriminate uh, can actually help a monopolist get the most out of its consumer base in terms of profits. And you can discriminate on the basis of units, uh, different market segments, like you have age, demographic, geographical location. Uh, there are many categories using which you can price discriminate. Uh, and then a firm with market power that can easily identify different market segments can maximize profits by charging a higher price for those segments where the consumers are not that sensitive to price, which is saying the demand elasticity is less. Uh, and then hodl pricing is basically if you're an impatient consumer, it's going to make you pay more. Like firms create obstacles that consumers have to overcome to pay a lower price. So like if you as a consumer don't want to put that much effort and you're fine with paying more, that's kind of the whole concept of hodl pricing, and that's how price discrimination allows firms to get more out of you. So the consequences of price discrimination is that it always provides a firm with high profits. So when you can understand your market segments and price them differently based on the characteristics of those segments, you'll end up having high profits. A monopoly that price discriminates will always produce more output than a monopoly that doesn't. And then if price discrimination leads the firm to increase total output, the total economic surplus generated in the market will also increase, and the outcome would be more efficient. Which is just a way of saying that since point two means that price discrimination will lead to more output, and a more output brings us closer to the equilibrium, and that reduces the deadweight loss, which is another way of saying it increases the total economic surplus. Okay, moving on to chapter 11. So monopolistic competition is what we have in most industries in real life, which is you have differentiated products. Each firm has access to the same technology. No firm has a direct effect on the other firms, and there's no barriers to entry and exit. So there's still competition, but it's not perfect competition. In the short run, a monopolistically competitive firm can maximize profits just like a monopoly. But in the long run, profits are zero due to freedom of entry and exit. So in the short run, again, when you have differentiated products, when you're not necessarily a price taker, your marginal revenue curves and your demand curve look like this. And in the short run, you can maximize profits by functioning on MR equal to MC. But in the long run, that's not possible. And that's because when in the short run, you as a firm in a competitive market are earning profit, that's going to attract more firms to enter. And just as we saw, it's going to shift the supply curve to the right, uh, to the point where the economic profits go to zero. Yeah, so that's the only difference between perfect monopolistic competition and a monopoly, is that in the long run, a monopoly can sustain economic profits, but not a monopolistically competitive firm because of freedom of entry and exit. Okay. Oligopoly is basically you have two or more firms, and at least one of the firms has a good portion of the total output that's being produced. And yeah, since there are a limited number of firms, they have the actions of one firm can directly affect the other firm, and firms can either maximize joint profits or compete to maximize their own profits. So this is kind of like a typical game theory problem. So you have two firms. When it's two firms, it's called a duopoly. This terminology. If they cooperate, they have large profits. If they compete, they have lower profits. But if one firm cooperates, the other competes, then the competing firm would end up with even higher profits. So let's look at the table here. So if let's say if firm A had two options, either to create either to cooperate and create a 50% monopoly, or to compete and have a higher than 50% market share. So whenever firm B also cooperates, they split the profits 50-50. So 20 million, 20 million. But when firm B tries to cooperate and then firm A tries to compete, firm A is going to have higher profits than firm B, but they're even going to be higher than the 50-50 split. And the same case for firm B here. And then if both firms try to compete, then they end up with lower profits. So it's still 50-50, but they end up with lower profits because competing requires resources. So which out of these four situations is going to happen is the Nash equilibrium? And before we get into Nash equilibrium, let's define it. So Nash equilibrium is that each player chooses its optimal strategy considering the behavior of the other player, and there is no incentive to deviate from a Nash equilibrium. Like deviating from a Nash equilibrium outcome doesn't make anyone better. Okay, so yeah, so think of it this way. So let's say firm A has decided to cooperate. Then firm B's ideal strategy would be to compete, right? Because compared to 20 million, 22 is more. So firm B decides to compete. Now let's say firm A decides to compete. In this situation, firm B would again choose to compete because 17 is more than 50. So regardless of what firm A does, firm B will always choose to compete. So, and going by the same logic, the other way around, firm A will always choose to compete, regardless of what firm B chooses, because same like when firm B cooperates, it's better for firm A to compete and get 22 compared to 20, and here it's better for firm A to get 17 compared to 15. So firm A will also always choose to compete, and that's why the Nash equilibrium is 17-17. Because there is no incentive to deviate from this option. But you see, this is not the option which is necessarily the best, because a 20 million profit is better. But just the way the payoff matrix is designed and the game is set up, the Nash equilibrium would be 17 and 17, which is both firms competing. Okay, let's move on to chapter 12. So chapter 12 basically talks about productive and allocative efficiency. Productive efficiency for a firm is that a firm should be producing at the output at the lowest possible cost. And for the industry, for the entire industry as a whole, it means that the marginal cost of production must be the same for each firm. that's when we reach productive efficiency. And then allocative efficiency is that the market price is equal to the marginal cost. So looking at the different markets, for perfect competition, everything's perfect. That's why it's called perfect competition, I guess. But yeah, so everything's productively and allocatively efficient, both the firm and the industry. For a monopoly, the firm and the industry are productively efficient, but as we saw, the price is greater than marginal cost, so it's not allocatively efficient. And then for monopolistic competition or oligopoly, firms are productively efficient, but so since products are differentiated, there's like no single industry-wide price, so it's hard to tell if the industry is productively efficient, because unlike perfect competition, products are differentiated. There's no single basis. But then for allocative efficiency, again, since price is greater than marginal cost, none of the neither monopolistic competition nor oligopoly is allocatively efficient. So this is just another way of like defining allocative efficiency. Allocative efficiency is when the sum of the consumer and producer surplus is maximized. So for instance, in perfect competition, if you function at point E, this area is maximized, so it's allocatively efficient. And that's the case. And yeah, that's what this graph is trying to show, like this total surplus is maximized. And then we see that in a monopoly, deadweight loss is created because we do not maximize this entire surplus area, and we function at the point where MR equals to MC, which is at this point here, and just extending this line above the demand curve and looking at the right of it, we see that this purple area is the area that's the deadweight loss, as we saw in the earlier graphs when we were looking at deadweight losses. So the concept of marginal cost pricing is basically saying we set the price where the market demand curve and marginal cost curve intersect. So here's the demand curve, here's the marginal cost curve, and if we set the price to here, we see that that's the outcome is allocatively efficient, but because price is equal to marginal cost, but a monopoly is going to suffer losses because compared to the long run average cost curve, the price is going to be less than that. And even though it's allocatively efficient, a monopoly would never do that because they're going to earn losses. So MC pricing will never be incorporated by a monopolist. Now let's look at average cost pricing. So this allows the monopoly to set prices to cover total costs such that there are no profit or losses. So your price is equal to your average cost. In this case, the outcome would not be allocatively efficient because the price is greater than the marginal cost. So it's the opposite of MC pricing, where we try to put price equals to MC. Here, we're trying to put put profits at zero, but that would become allocatively inefficient because the price becomes greater than marginal cost. But the firm breaks even. Yeah, so that was everything from chapter 1 to 12. I hope this helped, and best of luck for your final.